Hi, my name is Craig Sipes, and I am a STEAM coordinator for the Los Angeles Unified School District. And today I'm going to be sharing with you some ideas about how science storylines can be used as a frame for UDL, especially in terms of phenomena and the student practice of modeling. Those two things in particular can be used to leverage um, a UDL approach to student learning and frame that approach. So let's dive in.
This presentation is going to tie in with thinking Sarah Aguinaga and Jose Rivas are presenting. Sarah will connect this work at the lesson level with 5Es and UDL, and Jose is going to use UDL, the UDL lens, to foster or to frame student-teacher interactions, student moves, teacher moves, for the purpose of helping students regulate and develop agency. This presentation will tie the research in of the universal design for learning with the science education research led by Mark Winchell at the University of Washington and ambitiousscienceteaching.org, in addition to the research led by Brian Reiser at Northwestern University and nextgenstorylines.org. In this session, we will focus on the design of units, thinking about units as storylines, and how the UDL lens can help sharpen unit design for all students. There are two frameworks here that we're talking about: designing units as storylines and designing units with UDL. So the question is, how might we use those two frameworks to amplify each other? So we're going to start with what might it look like. Then we'll get into the frame, and then from there we're going to jump into connecting it to UDL. So let's start with what it might look like. So here's an example of a unit that might be something you're able to implement with distance learning. Um, I was a little bit shy in presenting this unit because I've not seen yeast in the stores for several months, but supplies seem to be slowly coming back to stores, and I found a lot of yeast the other day in a store. Nevertheless, this is definitely something you can do in classrooms when we return to the classrooms. The topic here is the topic of cells. This is for middle school life science. For us in California, using the integrated model for middle school, this is going to be a 6th grade unit. However, this could be adopted to different grade levels. The idea here is that even though the topic is cells, it's going to be taught through the perspective of a storyline. It's going to be anchored by a phenomenon, which in this example is the phenomenon of fluffy bread. There's a picture here of a large fluffy loaf. It doesn't exactly look like a loaf of bread, but that's a loaf of bread. Then there's a smaller loaf of bread. The anchoring question here is, what happens in yeast to make bread rise, and why does the yeast do this? This is the scenario. This is how this is presented to the students. The teacher brings in these 2 loaves of bread, freshly baked. Students can smell the bread, they can see the bread, touch the bread. Maybe they're even given the chance to taste the bread. If this is done with distance learning, then maybe the students bake these loaves of bread at home. The loaves of bread are then cut in half in cross sections, and the cross sections are shown to the students so that the students can see the structure on the inside, and they can see the crumb structure of the bread, that it's very different. The big, large loaf on the right is a fluffy loaf with large pores. Students can see the pores. On the left, the smaller loaf, the students can see a much denser structure with smaller pores. The teacher then gives the students the list of ingredients and the baking instructions for the 2 loaves of bread. And they're told the 2 loaves are baked in exactly the same way. Students are then asked, what do you notice? And what do you wonder about the baking directions here? So the students look over the the instructions and they see that everything is the same except for one thing. The only thing that's different is that the large loaf has yeast and the smaller loaf doesn't. So you can guess which one is the one with the yeast. It's the big fluffy loaf. So this serves as the anchoring phenomenon from which the students go through and notice and wondering sequence. The teacher doesn't give the anchoring question from the beginning. The teacher listens to the noticings and the wonderings of the students and helps to coalesce these noticings and wonderings down to the central anchoring question based on the anchoring phenomenon. After that, students are given the opportunity to write down their initial thinking. We call this the initial model. So there's an image of a large fluffy bread and an image of the bad or dense bread, the unfluffy loaf. The students are given a chance to draw in the little boxes here if they want to, and the drawings may be something that helps to explain their thinking, and they're also encouraged to describe their thinking in terms of words, use words to express their thinking. But the question here is, why did the fluffy loaf get fluffy? And why didn't the flatter bread get fluffy? So of course, yeast is involved, but we'll ask students to dig a little bit deeper. So what do you think is going on with the yeast? This is what the students would be prompted and prodded to address. The students are given an opportunity to fill that in. This is a way to gauge students' prior knowledge. This is a way of getting kids on the hook with getting them to invest in some initial thinking to make the learning their own, and a way of sparking questions. And at this point, they're just guessing. All answers are accepted, all responses are accepted. Students will not be graded down on any responses here. This is just a formative assessment and a way of getting the unit started. So from here, students are going to then develop a final model. Here we can see there's an example of a student's final model. In the final model, the student drew a slice of bread. And then there's a zoom in bubble. From that slice of bread, you can see that here there are little CO2 and H2O molecules and a yeast cell. Then the student drew in a zoom in bubble onto that yeast cell. And you can see in the yeast cell that the student has drawn the cell walls, a lysosome, the nucleus, the cytoplasm, and the mitochondria. Then the mitochondria is zoomed in on, and in the zoom in there, the student illustrates the glucose and the glucose molecules and the oxygen, and how inside of the mitochondria those go into forming carbon dioxide and water. So the student explains all of this and develops the storyline from the slice of bread going back, tracing back all the way back to what's happening in the mitochondria through the cell. So this is the story here. This is the storyline that's developed, facilitated by the teacher, but carried out by the students. And central to this is, up here, there are directions given by the teacher, but these directions include that students can draw and explain how yeast makes the bread. Now, there's a lot of student choice that can happen in here as to how they do this. But there are some must-haves, and the must-haves are listed here. And ideally, the must-haves are something that students work on together to come up with. So how did students get there? Students got there through a carefully designed unit that was tracked by this activity log. This is just the beginning. If you wanted to see the rest of of the activities, then they're available on ambitiousscienceteaching.org. But this is just the first three. So we saw then the first activity, the students looked at the ingredients of the risen and unrisen bread. They looked at what they did, and they looked at what they learned, and then through discourse in the classroom, they talked about how it connects to the overarching question, to the phenomenon. And so they go through and they do that for every single lesson. Every single lesson at the end, talk about what they did, and what they learned, and how it connects to the phenomenon. So this is the basics, and now we'll get into the frame. This is the basics of the unit. I'm not going to go into terrible detail here, but that was the basics. Now we'll get into the frame. So one way to think about the unit is to think about it in an arc or in a storyline. And so in the arc or in the storyline, then students are presented with a phenomenon. Teacher chooses a phenomenon, a relevant, engaging phenomenon that students will want to ask questions about. The teacher facilitates those questions through noticings and wonderings. Then they coalesce down to an anchoring question or a driving question for the unit. The students construct an initial model, which we looked at a template for that, and then students go through lessons. It could be three. Three is sometimes the magic number. It doesn't have to be three. After 3 lessons, then the students are given an opportunity to go back and to refine their model based upon what they've learned in the 3 lessons. And each one of these lessons, students are reflecting and connecting, and that helps them to refine their model. This is another formative assessment point. Then the teacher then moves on and provides more lessons based upon what the students need still in order to arrive at the full explanation, the full final model, which we saw an image of, a student example of. So this is facilitated by the use of the anchor chart that we saw an example of to keep track of the storyline on the wall, as well as student journals. So here is a second representation of this storyline that we're talking about. This one comes from the work of Brian Reiser at nextgenstorylines.org. And we'll go through this kind of piece by piece to look at how this plays out. So in doing so, we'll connect it to UDL. So step by step, let's go. So the first step here is the anchoring phenomenon routine. And for the unit that we talked about, it was a loaf of bread. And so students are exposed to the anchoring phenomenon. They try to make sense of the anchoring phenomenon. And with the help of teacher and whole class discussion, they identify some maybe related phenomena. Students can brainstorm on that, and teacher can help with that. And they develop questions and next steps. So this connects to UDL, and UDL helps to amplify these things by reminding us about how to engage students, how to offer representation to students, and action and expression. So here, UDL reminds us to foster student choice, to present, to give opportunities for multiple modalities, which these two play in with how students are going to show their learning, which goes into authentic student products. It also comes into play with the use of practices. Which practices are students going to engage in? The students will engage in different practices, which will engage different modalities. And through this process, we are expecting students to draw upon prior knowledge. We know that they have prior knowledge, and so we're accessing that prior knowledge, and we're helping students to construct new knowledge and build on top of that prior knowledge. From lesson to lesson, How do we work with students to motivate the next step in the investigation? So we're always looking backwards and forwards in this. So looking back, where did we leave off in the last lesson? What have we agreed upon? What are we not sure about? And then in moving forward, what are we trying to figure out? Reminding the students, what is the big idea here? What are we trying to do? And what questions do you still have? What might we work on next? These are all questions that are posed to students in discussion. In here, the UDL reminds us uh, that this is another chance to foster student choice, to provide agency for students as they're going through this, that they are important in figuring this out. They're given the power to help craft the questions that are going to come up next, that they're going to investigate. And students reflect and build on prior knowledge as they're going through. This is a graphic showing that connection. So this is a second representation of what we just spoke about in the prior slide. In this slide, we're looking at an investigation routine around the question of how do we help students use practices to figure out pieces of the science ideas. And so the whole point uh, of this is that students are going to generate questions through talking to each other, talking in whole class. Those questions are going to be connected to a phenomenon. Teachers may find an additional investigation phenomena that can tie into the questions students generate. The students engage in practices once again to try to figure out what's going on with the phenomenon. They construct knowledge. If your state has NGSS, which not all states do, then you are familiar with the term DCI, disciplinary core ideas. If your state doesn't have the next generation science standards as standards, then here we're simply just talking about content pieces. And with the cross-cutting concepts, the CCCs, we're talking about patterns. How do we identify patterns? How do we help students identify patterns? How do we help students to construct ideas around structure and function, and seeing that across different disciplines? So these are cross-cutting concepts. Through this process, once again, we're engaging students in letting their choice help to drive the learning. Once again, engaging in multiple practices and multiple modalities. Students reflect on and build on their prior knowledge and continue to create authentic products. At the end of an investigation, sometimes students, when it's an authentic student product, they might come up with two possible different answers to questions. In investigating a phenomenon, there may be two ideas that come out from the student investigations. There may be a group that comes up with solution A or explanation A, and then another group which comes up with solution B. And so rather than the teacher saying, well, solution B is the correct solution, then the teacher can help to ask questions. So how would we know? Students, how would we know if solution A is the better answer, or if solution B might more fully help to explain this investigation phenomenon? And what question can we ask, and what investigation might we do in order to help figure that out? Once again, UDL helps us to see that we are here fostering student choice. We're bringing in, we're offering once again through the use of practices, multiple modalities, and students are reflecting on their prior knowledge and the constructed knowledge that they're continuing to build on. And we're respecting their authentic products, and we are engaging them in digging deeper into those products. Then we have sense-making routines. How do we help students put together pieces of disciplinary core ideas and cross-cutting concepts? Here we're looking at bringing things together. This is in reference to then building on that understanding the the phenomenon, helping to construct the ideas of the phenomenon through the use of the investigation phenomena. So building up to the anchoring phenomenon, little pieces, little investigations, lesson level investigations contribute to helping to build that whole storyline. But that might necessarily be the end of it. Um, you may then need to continue on in more building. But all along the way, we are continually engaging students by fostering student choice, by presenting opportunities for multiple modalities, building on student prior knowledge and helping them to reflect and build and construct new knowledge, and continuing to help to provide students with multiple opportunities for authentic products. So all of this is driven by curiosity and multiple levels of sense making. And that leads up to the completion of uh, that bread unit, where students are constructing the idea of the reason why the bread is fluffy is because of what happens inside of yeast cells, but not just one yeast cells in bulk. Thank you so much.